Welcome to the Teach You Everything podcast. Today we are going to go over aplastic anemia. Let's start with the definition and core features. Aplastic anemia is a serious bone marrow failure syndrome defined by two hallmark features that always appear together: a profoundly hypocellular bone marrow and peripheral pancytopenia. To understand what hypocellular means, think of the bone marrow as a factory that manufactures all blood cells. In aplastic anemia, that factory has essentially shut down. The shelves are nearly empty of three critical worker lines. The first are erythroid precursors, the cells that go on to become red blood cells. The second are myeloid precursors, the cells that become most white blood cells. The third are megakaryocytes, the cells that eventually become platelets. Because the factory has stopped producing, the bloodstream reflects this catastrophic shortage across all three cell lines simultaneously. Anemia develops from the red cell deficit. Leukopenia develops from the white cell deficit. And thrombocytopenia develops from the platelet deficit. Together, this triad constitutes pancytopenia, a word that literally means a deficiency of all blood cell types. On top of all this, reticulocytopenia is also present. Reticulocytes are immature red cell precursors that would normally appear in the bloodstream as a sign that the marrow is at least attempting to compensate. In aplastic anemia, even these are absent or severely reduced. This confirms that the marrow is producing essentially nothing at all, and there is no meaningful recovery attempt underway. There is an important nuance hidden in the phrase almost total loss of hematopoietic cells that we need to unpack carefully. The destruction in aplastic anemia is not necessarily absolute. Even in severe disease, tiny remnants of surviving stem cell populations may still be present within the marrow. This distinction turns out to be enormously therapeutically significant. Here is why it matters. If some residual stem cells survive, and if the autoimmune T-cell attack driving their destruction can be adequately suppressed, those surviving cells may retain the capacity to reconstitute marrow function over time. This is part of the reason why immunosuppressive therapy can sometimes allow meaningful recovery, even without a bone marrow transplant. The presence of even a tiny surviving stem cell pool is therefore not trivial. It is the biological foundation upon which non-transplant therapy rests. And it is precisely why the distinction between near-total and truly absolute marrow failure matters in real clinical decision-making. Aplastic anemia, even in its severe form, is not always fatal if the right treatment strategy is applied at the right time. In the next video, we will go over the causes of aplastic anemia.